In this section we're going to look at three generalisations to the simple functional. So the simple functional that we've been using throughout this course is of the form I is equal to the integral from a to some point b of a function f over x, y derivative by dx. Now we want to extend on this, and we're going to do it in three different ways. So the first one we're going to look at is the integral from t0 to t1 of a function of t, and we're going to have our what are called generalised coordinates. So we're going to have our q1, q2 to qn and our q1, q2 to qn dash all by dt. Now these values q1, q2, qn are what we can call generalised coordinates. So for example, they could be our Cartesian, cylindrical or spherical coordinates. Now we've actually already seen this type of generalisation to the functional in the first course whenever we looked at the equations of motion of an object falling under the force of gravity. Whenever we looked at that video, we derived the we worked out the Euler-Lagrange equation for a particular Lagrangian, and we worked it out in terms of the y-coordinate, and we also worked it out in terms of the x-coordinate. So if you're unsure, you can always go back to that video and have a look. So all we're really doing up here is we're extending the Euler-Lagrange to different coordinates. So in this instance here we have an Euler-Lagrange equation which we can work out for the y-coordinate, and an Euler-Lagrange we can work out for the x-coordinate. So in terms of the equation above here, we could say that our q1 here would be equivalent to our y, our q2 would be equivalent to our x, and our q1 dash would be our y dash, and our q2 dash would be our x dash here. So there's nothing really new in this, and we'll work through this in terms of second variation and the conjugate points. We won't go into all of the details, but we will cover enough in order for us to have a reasonable understanding. Now we're also going to go into the second type here, and this is going to be a function of our x, y derivative, y double derivative up to the nth derivative. Again, we'll look at the second variation and also the conjugate points in this example as well. Now lastly, we're going to look at a function of two independent variables. So rather than just having one independent variable x, we're going to have an independent variable x and y, such that we're going to have a function of x and y, and z will be that function of x and y, and we'll have our p and q, where our p will be our partial z by partial x and q will be our partial z by partial y. Again, we'll look at the second variation and the conjugate points for this example as well. Now, of all of the three of these, the one that we're going to spend most time on will be the third one. And hopefully whenever you look through the third one, you may get a little eureka moment. But more of that whenever we actually go on and study this type of functional. So let's go ahead and we'll look at each of these three generalisations to our simple functional. Thank you for listening. I'll get you on the next video. Goodbye.